I'm Anil Kumar. We'll solve polynomial inequalities in this particular video. Let's begin with a linear inequality. So we have 3 times x minus 1 divided by 4, which is greater than or equal to x over 2 minus 1. Now let me rewrite this. Then we'll solve it by multiplying both sides by common denominator, and that will help us to remove the fraction parts, right? So the idea is, whenever you have something like this, if I multiply by 4, which is the lowest common multiple for 2 and 4, so because lowest common multiple is 4, if I times everything by 4, then what happens? Then we really get rid of the fraction part and it becomes a linear inequality, correct? So if I do that, then you can clearly see that I could write this equation as 3 times x minus 1 is greater than or equals to 2x minus 4, correct? This 4 and 4 cancels out. That's the whole idea. And here we get 2, and 1 times 4 is 4, right, with a negative sign. Now we can actually open the bracket. We have 3x minus 3 greater than or equals to 2x minus 4. Bring the x's together, 3x minus 2x, the numbers on the other side, and we get x is greater than or equals to minus 1, correct? So that becomes the solution. So we can write down solution in number of ways. One could be on a number line. So sometimes it is specified in the question. So in this case we have x is greater than or equal to minus 1. So let this be minus 1. And we have to fill it up since this is equal to also. Or you could write this as minus 1 to infinity in interval notation, right? So that is how you could actually solve it. I also prefer to check my solution. To check, we have to see 0, right? The question is 0 a part of solution? That is what you have to ask. That is to say, if I substitute 0 here, what happens, right? So if I substitute 0 here, I get, let me substitute 0 in the given equation. I get x is 0, so I get minus 3 over 4, and this is greater than equal to 0 will make this 0 minus 1. And is it true or not? Yes, this number is greater than that. It is definitely greater, and therefore we say that this is true, and we also say that 0 is part of solution. Is it okay? Part of solution. You don't have to write and all those. You can do this a mental check. So we know 0 is somewhere there, and it is within our solution, and therefore we are sure that the solution is correct, right? So to begin with, whenever you're working with polynomial inequalities, solve and then check using 0, right? So we'll apply this strategy with another polynomial inequality. This one I took just to show you that don't be afraid of fractions. We could always make it something like this, which is a linear inequality, right? So let's take up the next example, which is right here. So the example now here is solve x to the power of 4 minus 4 greater than 3x squared. So you can bring 3x squared to the left side. So we have x to the power of 4 minus 3x squared minus 4 is greater than 0. Now this can be factored. We're looking for a product of minus 4, sum of minus 3. So think like quadratic equation in x square, okay? So it could be written as x square. We are talking about minus 4 and 1, x square minus 4 times x square. Now since we need minus 3, it has to be plus 1, right? And when you multiply these two, you get minus 4. So it is not minus 1, it is plus 1 greater than 0, right? Now this can be factored as x plus 2 times x minus 2 times x squared plus 1 greater than 0. Now, when you have a polynomial inequality, something like this, you could adopt a couple of methods. One of the methods is graph itself, right? One of the methods is graph itself. The other one is the intervals we talk about. So what we will do here is we'll begin with the intervals and check with the graph. We have two zeros here. So the zeros are at x equals to plus and minus 2. This function is always positive, never 0. Is that okay? So there are two zeros here. One is at minus 2, the other one is at plus 2. So we'll actually test the intervals because these zeros are linear and the function is going to change the sign at both these zeros, right? So one is at minus 2, the other one is at 2. So what we do here is, we know these two zeros, let me put like this. Since we are working with greater than, we will not be including zeros in our solution, right? So these zeros divide into three different intervals. One interval is from minus infinity to minus 2. The other one is from minus 2 to 2. And then we have from 2 to infinity. Now in these intervals, you have to select test points. So let's take a test point in each interval. Let me call this as TP. So this is be minus 3, that could be 0, and here we could take 3 as a test point, right? Okay. Now we have to test these factors. What happens to these factors at these points? Whether they are positive or negative, right? So if I write x plus 2, x plus minus 2, and x squared plus 1, substituting minus 3 will make this negative. However, these two will be positive. For x minus 2, if I substitute minus 3, this will be negative. 0 will also give me negative. 3 will make it positive. As you know, this function is always positive. Now we are talking about product of these three, right? So we are talking about product of these three. Two negatives makes it positive. One negative is negative. All positive is positive. Greater than 0 means we are looking for positive, right? So we are looking for these two intervals. So from here, we know that the solution is that x belongs to from minus infinity to minus 2 union 2 to infinity. Is it okay? 2 to infinity. Now this is one method which we are testing with the help of intervals, making a table. The other method is to sketch, right? So let me call this as method 1. Correct? And now I'll do method 2, which is just a sketch. So we know this is a polynomial, even degree, both sides both going up, right, and two zeros. So that is the polynomial. So whatever happens, it is going through like this. I mean, let me use a different ink. Okay, let me use a different ink. Let me use black. Okay, that's fine. So it goes kind of like this, something, something, and we are not going precisely with the graph, but with the nature of the graph. So what you see here is that this side is positive. Do you see this side is positive, greater than 0, and that's the part of our solution. So sketching is very fast, very effective way to solve inequalities for polynomials. Sometimes if it is not mentioned, you should follow sketching. That's my preference. I hope that really helps you to understand how to solve polynomial inequalities. If you see fractions, then get rid of fractions by multiplying each term by the lowest common denominator. And if you see a polynomial, you need to factor it. You can adopt the method of sketching to find the solution, or interval where the function is positive or negative, as shown here. I hope that helps. Feel free to post your questions. Subscribe to my videos, and if you like, that'll be great. Thank you and all the best.